Hi, I'm Pascal, and today I will talk about GraphQL Open Telemetry. I'm co-founder and CEO of ChilliCream. We do all sorts of GraphQL tooling and are best known for our GraphQL server Hot Chocolate and our GraphQL cockpit Nitro, which is here in the background. And we are also known for leading the composite schema group, which you just have seen in the talk before. Before we dive into the details about OpenTelemetry, let's first catch everyone up in the room what OpenTelemetry is. OpenTelemetry is an open source project under the CNCF Foundation that gives you a consistent way to collect observability data across any language, any platform, and any service. It's completely vendor neutral, so you're not locked in to any toolset or backend. And there's countless of vendors which provide OpenTelemetry integration. The nice thing about OpenTelemetry is that when you use one of these vendors, you should actually be able to just switch to another vendor by changing the connection string in your application, and there should be no code change required. OpenTelemetry covers three main signal types. We have tracing, we have metrics, and we have logs. Traces tell you where the time goes in a request. Metrics help you track the health of your system over time, and the logs tell you what exactly happened in a request. This is a full distributed trace, specifically of the homepage query, and the top level bar here represents the HTTP spans, and the yellow bar at the bottom, very tiny, we'll see more of them in the near future, are database calls. Each span has attributes, which are key value pairs of metadata that are added. Then logs give you the narrative of what happened in a request. Classic logs are a timestamp and a message. With OpenTelemetry, you also have attributes that are added to them. Logs also carry the trace ID, so you can very easily correlate them with your traces. A good example for metrics is a dashboard like this. These dashboards give you a top-level view over your GraphQL performance over time, and it's these dashboards that answer very quickly the question, is my system healthy or do I have an error? Especially when you pair this with tracing, it's really powerful. Another good example is this overview over federated Fusion Gateway. And in this specific example, the metrics are aggregated based on trace data, so not real OpenTelemetry meters, but it gives you a sense that numbers that you see like this usually are metrics. So, first audience participation, who is using OpenTelemetry with GraphQL? Fantastic, so still a few people to convert. For the ones that use OpenTelemetry, you probably ran into something which I call the /GraphQL problem. When you use OpenTelemetry and you just plug it into your server, what you will see most likely is going to be this. /GraphQL and all your traces, operations are grouped under it. So all mutations, subscriptions, if you use SSE, and queries are just /GraphQL, which is pretty useless. And it doesn't really matter which system you take. For example, here is Kibana /GraphQL. There's also Datadog, Azure Monitor. Most of the vendors have this problem. It's the unfortunate truth that observability platforms are optimized for REST. And if you think about it, in REST, this makes a lot of sense because all of the routes usually, well, the method and the route together are an action that you take on your server. In GraphQL, you should really only have one endpoint. If you have more than one endpoint, you either have done something wrong or you have done something very right when you use trusted documents with with trusted document routes. What we actually want is something like this. We want a clear overview over what operations were executed, their performance characteristics, and so on. The reason why most telemetry systems cannot handle this is because they don't understand what GraphQL is, and they don't understand how to interpret the traces. So how can we fix this? The OpenTelemetry specification has an answer to this problem. The specification defines a set of well-known semantic conventions. These are standardized attributes like the HTTP response status code And these conventions define what to record, and they are available across all of the different languages, because an HTTP status code is a fact that is the same in JavaScript as it is in Java or C#. The semantic convention also defines what type this is and the description, like this has to be an int, and it has to be an int which is defined in the RFC 7231, which you can read after this talk is over. Yeah, so it's completely independent of what technology stack you use. These conventions have a consistent meaning across teams, languages, and so on. And by honoring these conventions, by GraphQL servers, for example, we make it possible that all of these vendors can use the same, can provide aggregations on top of this data. So once we have good semantic conventions defined, all that vendors have to do is to add the aggregations, and then we have nice dashboards in all of these vendors. The good news is that we already have semantic conventions for GraphQL. The bad news is they are implemented and the providers do not really care about them. There's currently only one span type defined, which is the GraphQL operation span, and it has these three attributes defined: the GraphQL operation name, the GraphQL operation time, and the GraphQL document. And please do not send the GraphQL document to your telemetry system every time you make a request, because that's just a waste of energy. So let's fix this, but how can we fix it? I'm not sure if you ever heard this quote, but Charles Kettering once said, if you want nothing done, form a committee. And honestly, he's got a point. Ali, how many of you do have a committee of architects, a committee of clean code, a committee of whatever in your company, and what's the output of these committees? Usually, not really much. So naturally, we did the only reasonable thing, and we formed a committee. So we founded a work group. So I want to offer a small update to this quote. If you want nothing done, form a committee. If you want something done, form a GraphQL work group. Yeah, so the GraphQL work group meets once every month and discusses how we can make the open telemetry GraphQL story better. We already have 11 contributors from companies like Apollo, the Guild, Shopify, Datadog, VMware, Microsoft, and PayPal. And we also have Trask on board, which is an employee of Microsoft and which maintains the semantic conventions on their side. And he has nothing to do with GraphQL at all. But you see that with these work groups, we actually get together the people which are GraphQL experts and the people from the semantic conventions repository, and then we can make a nice specification. And these work groups are open. The next one is on the 25th of September. So if you want, please join. And you can just sign up for these work groups when you go to the GraphQL organization, GitHub, and then go to otel-wg and then sign on. OK, so let's dive into what we have defined. Open telemetry is usually used across the whole stack. So it doesn't just cover the GraphQL server, it also covers your HTTP server, so Kestrel, Express, or whatever you use. So usually the first span that you see is the GraphQL span, the HTTP span. And the next span usually already is the GraphQL operation span. This spans, by the way, spans. I will say this like 50 times in this presentation, so be aware. This spans the execution of the whole GraphQL request. The attributes on this span are the operation name, the operation type, we have the document ID, and we have the document hash. There's one problem with this. And this problem is that the span name, which you can see here, is the operation type and the operation name. And to understand this problem, we first have to understand what cardinality is. Cardinality is the number of unique value an attribute can take, an attribute name can take, or a span name can take. Attribute values can have high cardinality, but the labels, they should have low cardinality. Span names should also have low cardinality. And this is important because if the backend expects low cardinality for a certain thing, and it receives high cardinality, then everything blows up. So it slows down your dashboard, your queries, it makes your alerting really noisy or completely breaks it. And it can also crash or degrade your tracing backend. But the biggest problem of them all is that cardinality explodes storage and compute costs. In GraphQL, we have to be careful as the operation name is passed from the outside. Attackers can use this to overload our system. So they can just send many, many requests with different operation names, and then they blow up our telemetry system. And it's very bad when you're attacked and you can't see. That's very bad. So what you have to do, by Benji, right? You have to use trusted documents. If you can, you should. If you cannot, poor you. Otherwise, just use query, subscription, and so on as the span names. Okay, so back to tracing. The next three spans are pretty self-explanatory. We have the parsing span, which spans the whole parsing, the validation span for the validation, and the variable recursion. While the variable recursion you always have when you have inputs, the parsing and validation usually you only have once if you have a good GraphQL server, because then it should be cached. And now we have the GraphQL execution span. And this includes the whole execution of the GraphQL stuff, so including all resolvers, data loaders, and so on. Now, the smallest piece that we have defined is the individual field executions. As traces are hierarchical, you can very easily correlate the field with the database request that it calls. So this one is the field, it's just the coordinate, and then you have the database request, which is a child of this. And this should be low enough cardinality. The attributes that we define is the selection name, which is exactly what you have selected. If you use an alias, this would be the alias. We have the path, which is a JSON path. And we also have details like the name of the field, the coordinate, and the parent type. Now, if you just trace all your fields, you will very quickly run into many, many issues. Your trace size will explode. You will pay much more real American dollars to the tracing provider that you use. And the value that it adds is very low because it's just too much noise in your system. The traces become barely readable, and you also have a huge overhead in application performance because tracing always comes at a cost. And don't forget this, even though it's very efficient, you always pay for tracing. So you have to find the right balance here. And we recommend one of these four approaches. You can either manually select what you want to trace. So you say query.me is a field that's interesting. You can use what we do in Hot Chocolate, where we say we just trace async resolvers. That's a feature of C#, where we say we have a promise, a task, which is an async operation, which normally includes I/O. And as soon as you have I/O, it's probably something that you want to trace. You can also do it depth-based, which is a common approach. You just want to trace the first two layers of your execution, because that's usually where the magic happens. Or you can do performance-based, so you trace only the fields which take longer than 10 milliseconds to execute, although this one is really hard to do in most languages. We also have already discussed data loader tracing, which would look something like this, where we introduce the GraphQL data loader batch span, and this batch then nicely groups the database call under itself. Otherwise, you just have random database calls in your application, and you don't know what caused them. It just defines two attributes at the moment: the name of the data loader and the batch size. So how many keys were fetched with this data loader. Once we talk about metrics in the work group, we'll also talk about data loader metrics, so you know the cache hit miss ratio that you have in a request by a data loader. Okay, so we've just seen composite schema, and we also have defined a few spans which could be used by distributed GraphQL servers. And the first one is the GraphQL operation planning. So every time you send a request to a server that is federated, it has to figure out where to get the data from. And that's the operation planning. Now, this can also be used by any other GraphQL server. For example, in Hot Chocolate, we have the GraphQL operation compiling, we call it, where we optimize the request that you have sent for execution. This could also be wrapped with this. A good example for this is also non-federated, the GraphFast engine by Benchy, which also have this planning step. During the execution, we then have the GraphQL step executions, which essentially are spans which span each execution step that you have. In federation, this usually means that you have one post request to a subgraph per execution step. And the attributes are the step ID, the step type, so is it a fetch, a node resolver, and so on, the plan ID, and what kind of plan this is. And this is where we are in the workgroup at the moment. In the next session, we will start discussing errors. And in Hot Chocolate, we currently just add them as events on the spans. And this way you can very easily show this overview, and you can very easily spot where something went wrong in your application. This is a bit in flux at the moment in the Open Telemetry specification, because they want to get rid of the events on spans. So they may use log events for this in the future, and then that's what we have to define in the specification, how we want to do this so that we are not obsolete the time we release it. This error then bubbles up and invalidates the whole query. And then your tracing backend just have to understand that even though we return 200 OK, that there actually was an error on this span. If you do this, then you can render these nice dashboards where you see how many errors have happened over time, and you can actually spot quite quickly what went wrong. Okay, so this was it about tracing. Let's skip to metrics. And while we have not really worked on semantic conventions of metrics in the workgroup yet. This would be a classic example of what you want as metrics, coordinate-based metrics. How often was this field used? How often was this argument used? How many errors were in this field? How long is the field execution? How many queries use this field? How many clients use this field? And all of these questions. And naturally, when you look at this, it's like OpenTelemetry meters, problem solved. But there's a problem with this. And it's meme time. So one does not simply collect metrics without running into cardinality issues. What does this mean? A meter, which is what you see on top, GraphQL server coordinate requests, can also define attributes. And there is an instance of this meter for all permutations of the attributes. That means that when you have coordinate in there, the field coordinate, then this is in the thousands if you have a small schema. If you have a big schema, in the tens, hundreds, or even millions. Because each member in your type system is going to have a coordinate. While the client ID here has low cardinality, non-issue, the client version is constantly growing. So if you have 5 clients and they like to deploy previews on the web, then this number is constantly growing. If you calculate all these permutations, you very quickly reach the limit of 2,000 per meter of the OpenTelemetry SDK. Again, the problem is telemetry explodes, and also the memory allocation grows because they always have to be in memory. This usually leads to an angry boss, which leads to a bad time, and this makes you sad. So, can we fix it? Maybe, or not really. So, coordinate-based metrics, the view that you have seen before, we aggregate this based on tracing data. We report which operation uses which coordinates, and then we aggregate it based on tracing. Just because OpenTelemetry meters are the wrong tool to do this. But there's many other things that we could do. We could have GraphQL server request, which counts how many requests there are, how many requests are active currently with an up-down counter, the validation duration, cost, and also the data loader metrics. Okay, so you could also add the operation ID, the hash, the name, and so on to these meters. But you have to be very, very careful, because you can only do this if you are below this 2,000 limit, or you just increase the limit, but then you're on your own. And if you use persistent operations, because otherwise you will have many, many issues. So whoever has an API which has more than 50 queries, don't worry about this. You probably have to aggregate tracing data. Okay, so the last pillar is logs. And we were like asking ourselves, what could we specify here? Like, there's not much that GraphQL would be able to log as an output. But the interesting thing is that the log signal can not only be used for classical logging, so we can add metadata to these log signals. So what we could use logs for, and this is very theoretical now, to do operation reporting. So that means that the first time a request is executed, and please only the first time, you just add a log signal, so you log something. It doesn't need to be in the console. You can just log it over the log signal. And you log the actual string of the GraphQL document. And then your backend knows that this hash has this huge GraphQL document. And then you can correlate it back. And the same thing you can also do for coordinate reporting. Because currently Hive or Nitro, Apollo, and whatever else has support for this, uses their own endpoints for this. So it's going to be very hard to switch from one provider to the other. Okay, so we're reaching the end. And I would like to make a rough timeline prediction. There's no guarantee, but we expect tracing to be done this year of the specification. And then we don't really expect that OpenTelemetry logs and metrics will take much more time. So the estimated time of arrival of the semantic conventions is somewhere early next year. That doesn't mean that it will be available in Datadog and all the other providers at the same time. That's just the specification that has then to go to the review process, and then someone has to implement it in their providers. But we're actually quite confident that we can make this quite quickly. And then let's hope that more vendors are integrating GraphQL into their system. Okay, that's enough from me babbling around OpenTelemetry. Do not hesitate to shoot me a message on the Word app, GitHub. Well, you can't really message me there, but send me a pull request or an email. You also have the information here in the QR code. And if you have any questions, now's the time to answer them. Yes, please.
Hi. Do you have any opinions on like multi-parent spans? So imagine you have like a field, or you have two fields that call the same data loader, right? So
yeah, that's a problem.
Yeah. I mean, I've heard that OpenTelemetry has been talking about multi-parent spans, but I
don't.
just want to know if you have an opinion.
I'm coming from the GraphQL ecosystem, so I don't really know what the OpenTelemetry Foundation, the OpenTelemetry team is doing about these things. But at the moment, it's by design, by API, not possible, because a span in the gRPC schema of an OpenTelemetry collector has a parent span ID, and it's very hard to point to multiple parents. Yeah. So it's hierarchical, and one of the traces will have it as a child.
Yeah, we've been doing like faux parent, like fake parenting using that, right? Where you like emit a single data loader span that's like kind of arbitrarily parented, and then like don't emit spans for the other fields or something like that.
Yeah.
But yeah, you lose some fidelity in the traces.
Yeah, you do. It's just good to have a data loader span, because otherwise you have random database spans somewhere in your trace, and you're wondering where they come from. Yes, please?
Yeah, there is something called span links.
True. That's right. So links is actually something that we have to explore when we talk about subscriptions, because what we found, it's pretty useless to have a subscription which is open for 30 minutes and doesn't have any events. What you actually are interested more in is that you see the subscription execution, so each event actually produces an execution, right? So these are the ones that you want to trace, and then you want to link to some parent span, which just takes an hour to complete. If you do not have these links, or if you just render everything into one span, it becomes barely readable, because you just have like a huge span, and then you have one straight line, which is the GraphQL execution of one of the events that we receive. But yeah, that's true. Span links are great. And you also have events, but I have the feeling that they go out. So we've talked a lot with Trask about this, and he mentioned that span events most likely will be deprecated at some point. So we'll lose the flexibility of this. Any other questions? Yes.
Just wanted to mention something, is adding to your point about the overhead.
Yes.
This is the best moment to talk about it. Someone in this room is using GraphQL Java. Never use the automatic instrumentation of the Datadog agent because there is no way to disable or select which fields you want to instrument and create spans for. We will create, if you use an query of 1,000 fields, they're going to be creating 1,000 spans, and you are not going to be able to disable and select like which ones you want to.
Yeah, you definitely don't want this. If you have the need for this, there is something. The OpenTelemetry guys are, the OpenTelemetry folks are cooking up something at the moment. So we have the 3 main signal types. We have metrics, we have logs, we have traces. There's a 4th one coming, and this is going to be profiling. And that's going to be exactly where this becomes interesting, where you can actually say that there was a request, and you see the whole stack like you would do F12 in your browser, and then see the JavaScript stack there. So there's something coming if you need this accuracy, but by default, don't enable it, because it really slows down everything, and it's just super expensive to do.
We were forced to do it manually with instrumentations. That's not fun.
Yeah, I mean,
So we don't have that problem, so we do use auto instrumentation with GraphQL Java.
Oh, but we use the Datadog agent.
Oh, right. So that's
Using OpenTelemetry.
the data log or Datadog?
Datadog.
Data log.
Datadog.
Datadog. Okay. All right.
Yeah.
Okay. Yeah.
Direct with an agent, so it creates span per field.
Yeah. Yeah. It's what we found is that the biggest problem, even if you don't pay, if it doesn't increase your tracing backend costs too much, because you self-host or whatever, the performance hit on the server is the main thing. It's
collection of those spans.
yes, yes,
Costs are horrible.
yes, and that's on the JVM, which is
Yeah.
super fast and super good at garbage collection, right? Okay. Yeah, please.
So I know there's a point we mentioned at the beginning that we want to answer questions like which client is using which fields.
Yes.
And we said OpenTelemetry is not the right solution for this because cardinality is accessible.
It's not the right solution. So that's what I mentioned before when we talked about metrics. What we GraphQL folks want is this. We want to know this coordinate is used 75 times over the last 30 days. I cannot deprecate it. This is the question we want to answer. But unfortunately, it doesn't help because you shouldn't trace all your resolvers because expensive and slow. And when you don't trace all your resolvers, how do you know if profile.name, which is a sync field, is resolved? So you don't have a span. So naturally, the answer would be, well, we just use meters for it. But that doesn't work either because we have too many coordinates. So most likely you have to, for this specific question, for coordinate-based metrics, so what we have seen, by the way, it's an absolute wonder that Keynote didn't crash in this presentation because it did every single time I tried this. This board we have working, but we don't use OpenTelemetry metrics to aggregate the data. What we do is we export the operation coordinates and send them to the backend separately. And then we just use the operation hash and the tracing data to calculate how many times this field was requested. But it doesn't work with meters. So that's something which you have to specifically build for GraphQL to work.
It's a custom search solution rather than relying on OpenTelemetry.
Yes, you have to have a system that supports this, yeah. Yes?
So the cardinality issue, would you say that's inherent in OpenTelemetry, or is that a function of the backends that are normally used for this? Because my impression is that this is actually the databases that have been built, the time series databases used for these signals that fall over when the cardinality gets too high, and that there are other implementations that fix this.
Yes. So you do not have cardinality problem. Ooh. Sorry. You do not have open telemetry wise. You do not have any cardinality problems in tracing. You can span whatever you want to the collector. You don't have them in logs because they are actually built for high cardinality. Where you do have specifically from the SDK limitation is in metrics. So only metrics have, there's even a field in the gRPC file of the OpenTelemetry collector which tells you that there's more permutations of, so more combinations of the attributes on your meter than what's supported. So it will only report 2,000 and it will tell you there's more, I can't report them. So with metrics, you have these issues. If you use tracing and your backend supports it, like we also have in Nitro, we have also built these views, right? So there's backends that can calculate these things. You just need to do it, they just need to be built into the tracing ingest. You cannot do this over meters because that's SDK limit. Anything else? Okay, cool. Thanks a lot.